Right, so let's look at a couple more of these polynomials that are just dying to be factored. Here we've got x to the fourth minus 3x cubed minus 6x squared plus 28x minus 24. I've got the synthetic division all ready to go. I just need to figure out what numbers to try in there. And I know from the possible rational roots theorem that factors of 24 are going to be the way to go. So that's 1, 2, 3, 4, 6, 8, 12, and 24. That's a lot of numbers to try. So I'm going to cheat. I'm going to go to the calculator, and I've already punched this in because you don't need to watch me type keys in the calculator. So there's a picture of this graph. I typed it in y equals, went to graph. That's a picture of the graph, and it looks to me like the x-intercepts are at -3 and also at +2. Not only that, remember when we talked about the behavior of the graph at the intercepts? This one has a wiggle, which means that the multiplicity of that 0 is more than 1, which means 2 is going to be a 0 more than one time. So let's look how that works out here. I'm going to start with 2. Bring it down, times 2, add, times 2, add, times 2, add, it's +12, times 2, 2 times 12 is 24, and that gives me 0. That's my remainder. That means I've found me a factor. Let's try 2 again. Right? This is our other factor, x cubed minus x squared minus 8x plus 12 is our other factor, and we got to factor that. Plug a 2 in, 1, 2, 1, 2, -6, -12, 0. So 2 worked again. I suspect it's going to work a third time. I know darn well it's going to work a third time. 1, 2, 3, 6, 0. Okay, so here, that's a 0. So x minus 2 is a factor. That's a 0. So x minus 2 is a factor again, and a third time. So x minus 2 cubed. And then our last factor comes from here. This stands for x plus 3. That is our third factor. And that does what we would want it to do, right? It goes through at -3 and goes through with a wiggle at +2. And that's exactly the behavior we saw in the graph. Straight through at -3, through with a wiggle at +2. Got another one here. We can set up our synthetic division. We got 1, 2, -20, -66, -45. And the numbers we have to try are the factors of 45, which there's a lot of, and I really don't care to list them, right? 1, 3, 5, 9, maybe 15. I think 15 works in there, yeah. So I don't want to bother listing all of those. I want to go straight to the graph and see what I think is going to work. And it looks to me like -3, -1, and +5. And because it bounces off at -3, that probably works twice. So -3, -1, and +5. Let's try our -3. 1, -3, -1, -3 times -1 is +3, -17. -3 times -17 is +51, which gives us a -15 there. -3 times -15 is +45. I haven't mentioned this, but if you need to use your calculator to do these calculations as we go through, that's fine, especially as we start getting into slightly larger numbers. I hope you don't have to use a calculator for -3 times +1. -3 should work again based on the behavior at the x-axis there. -3, that'll give us -4, +12, -5, and then +15, which gives us a 0. Okay, so negative 3 works twice, which means two of our factors are x plus 3. Now you can continue with synthetic division if you want, or you can look at this and know that it is x squared minus 4x minus 5, and you can factor that by hand more than likely. Right, you know these two numbers have to be 5, so it's got to be 1 and 5, and if that middle term is going to be 4 negative, then it has to be minus 5 and plus 1. So x minus 5, x plus 1, and that is our factored polynomial. Right, that's that. We'll move on to the last section in this part of the course.